Hi everyone, and from today onwards we are going to do a journey with the most beautiful subject, that is electromagnetics, right? Okay, so from today onwards we are going to start the journey with the subject electromagnetics. The subject electromagnetics. So in this lecture I am going to give you what is the weightage of the subject for EC students in GATE exam, and also I am going to give you the brief view of the, or I can say overview of all the topics that we are going to cover in this subject, right? Okay. So here we are going to cover the syllabus for EC students here, the syllabus for EC students. So generally the weightage of this subject for EC students will be around 8 to 12 marks. We can expect from 8 to 12 marks on an average, okay, for EC students. So this is the weightage here, this is the weightage in GATE exam for EC students, right? Okay. So generally the students will feel this subject as a very difficult. See, the reason is in general here, in all the other subjects you are going to deal with what? In all the other subjects you are going to deal with voltages and currents, or voltage signals and current signals, etc., right? So in all the other subjects you are going to deal with voltages and currents, and these voltages and currents are nothing but what? Are nothing but scalar quantities, right? So in all the other subject you are going to deal with the scalar quantities, and students are very much familiar in dealing with the scalar quantities, and they are also very much familiar in dealing with the scalar operations. So that's why they can easily understand the other subjects. Whereas coming to our subject here, that is electromagnetics, here we are going to deal with electric field and what? And magnetic field. So the magnetic field in generally I will represent with H field, or in sometimes I will represent with B field. Okay, so I will explain each and everything as we proceed into the subject. So generally we are going to deal with electric field and H field. So these are nothing but what? These are nothing but vector quantities. These quantities are nothing but vector quantities. Okay, so throughout our subject we are going to deal with these vector quantities here, with these vector quantities, and also here we are going to deal with vector operations. Here we are going to deal with vector operations such as dot product, cross product, and we are going to deal with a differential operator. So there we are going to see gradient, divergence, and curl, etc. Okay, so in generally the student is not that much familiar in dealing with the vector quantities and in dealing with the vector operations. So that's why the student will feel difficulty in learning this subject, whereas other subjects they are going to deal with only scalar quantities. So dealing with the scalar quantities is very much simpler when compared to dealing with the vector quantities. Understood? Okay, so this is the main reason why the students are not that much comfortable in learning this electromagnetics subject. Okay, so that's why in our lecture what we are going to do is first of all, for the few lectures we are going to develop the mathematical foundation. That means initially we will concentrate only on the basic mathematics part that is needed for us to understand the subject clearly, right? So for the first few hours we are going to spend most of the time in order to learn the basic mathematics part that is needed to understand this subject. Understood? Okay, right. So now I have given here the weightage of marks for this subject for ECE students, that is from 8 to 12, and I have given the reasoning why the students will feel difficulty in learning this subject, right? So next I will give you the overview of all the topics here. So that means I am going to list out the topics that we are going to cover in each and every lecture, right? Okay. So next, write down. So take pen and paper here. So whenever I am listing out, so you also have to write in your notebook, right? Okay then. So write down the topics. Write down the topics that we are going to cover in this subject, right? Okay. So the first one we are going to cover is a introduction. Just I will give you the brief view of electric fields, magnetic fields and electromagnetic waves, right? Okay. And also I will give you what is the importance of the electromagnetic waves and all those things in this introduction lecture, right? Okay. Next, second topic, we are going to cover basics of vectors. Second topic is basics of vectors. Next, third lecture is coordinate systems. Coordinate systems. The third topic is coordinate systems, right? Okay. Next, in coordinate systems, we are going to cover rectangular or Cartesian coordinate system, and here the coordinates are nothing but x comma y comma z. Next, we are going to cover cylindrical coordinate system, and here the coordinates are nothing but rho comma phi comma z. And next we are going to cover spherical coordinate system, and here the coordinates are r comma theta comma phi. Okay. So once we complete this coordinate systems, then right. So once we complete the coordinate systems, next fourth topic, we will go for a vector differential operator. Vector differential operator, or we can simply call it as a del operator. So generally we will represent this with a del here. This is the symbol that we are going to represent. So in vector differential operator or del operator, we are going to study about the gradient operation, and then divergence, and then we are going to study about curl, right? So these are the topics that we are going to cover, that is in vector differential operator. So del operator or vector differential operator both mean same. So in this topic we are going to cover what do we mean by gradient operation, and what do we mean by divergence operation, and what do we mean by curl operation, and also their physical interpretations. Okay, so the physical interpretations of these operations is very, very important, right? Okay. So this is the basic mathematics part that is needed for us to understand this subject. So this basics of vectors, coordinate systems, and this gradient operation, divergence operation, and curl operation. So this is the basic mathematics part. These three topics, that is second topic, third topic, and fourth topic. These are the three topics that is needed in order to that is the mathematical part that is needed in order to understand the subject. Understood? Okay. So once we complete this mathematical part, right, then we are going to enter into the actual topics of the subject. See, you should not neglect this mathematical part here. Why means this is the soul of the subject. Understood? Okay. So if you understand this mathematical part in a crystal clear manner, then you are going to understand the subject in crystal clear manner. Okay, if and only if you understand this basic mathematical part. Understood? Okay, so don't neglect this part here. So this is very, very important, right? Next. So I have written up to 4 topics, right? So next, 5th topic. So 5th topic, I am going to start electrostatics. So actually speaking, you are not having in the syllabus of EC, so they have not mentioned this electrostatics topic here. They have removed this electrostatics topic, right? Okay, but still we have to cover few topics of electrostatics. Understood? So we are not going in depth of all topics of electrostatics here. We have to cover the minimum topics in electrostatics. Understood? But in the syllabus they have given as Maxwell's equations. So in electrostatics we are going to get Gauss law for electric field, which is nothing but one of the Maxwell's equations. Okay, so that part you have to cover, right? Okay. So in electrostatics, what are the topics that we are going to cover here is we have to understand what do we mean by electric field, right? So once we understand what do we mean by electric field, then we have to study Gauss law. So Gauss law for electric field, Gauss law for electric field, right? So next, Gauss law for electric field. So next, after this, so we are going to study in depth about this Gauss law for electric field and also its applications. Understood? Okay. Next, after this, we will just study the brief view of electrostatic potential. So here just we will see the relation between the electrostatic potential and electric field. Okay, so just we are going to have some brief view of electrostatic potential. Understood? See, irrespective of the syllabus, you must have some brief knowledge about this topics here, right? Okay. So here we are going to cover this as a brief view. This is nothing but a brief view of electrostatic potential. So this topic also we are going to cover, right? Next is a 6th topic here. So that is magnetostatics. Okay, so in magnetostatics, what are the topics that we are going to cover? So in magnetostatics, what are the topics that we are going to cover? See here, in magnetostatics we will cover brief view of Lorentz force equation and also Biot and Savart's law. Okay, so we are going to have the brief view of Lorentz force equation and Biot and Savart's law right? Okay, so once we complete this, here just we are going to have the brief view of this topic here, right? Next, after this we are going to cover Ampere's law. So after this we are going to cover Ampere's law, right? So this is important here, okay? So Ampere's law. So next, once we complete Ampere's law, next we will cover Gauss law for B field. We will cover Gauss law for B field. So it is very simple topic here. Gauss law for B field is very, very simple topic. So with this we are going to complete this magnetostatics part, right? Okay. Next after this the 7th topic is time varying fields. So we will enter into time varying fields. Okay, so in time varying fields we are going to cover Faraday's law and modified Ampere's law and modified Ampere's law. Okay, so these are the topics that we are going to cover. These are the topics that we are going to cover under what? Under time varying fields. So this is the 7th topic. Understood? Okay, okay. So if you observe here, of all these topics, right? Okay, see here, Gauss law for electric field. Gauss law for electric field. Gauss law for electric field is nothing but Maxwell's equation. Maxwell's equation 1. So this is the first Maxwell's equation we got here, right? So in electrostatics, this Gauss law for electric field is nothing but the Maxwell's equation number 1. Next, in magnetostatics, this Gauss law for B field. Gauss law for B field is nothing but the Maxwell's equation number 2. Maxwell's equation number 2, right? Next, here this Faraday's law. This Faraday's law is nothing but the Maxwell's equation number 3, right? And this modified Ampere's law is nothing but the Maxwell's equation 4, right? So from electrostatics we got one Maxwell's equation, and from magnetostatics we got another Maxwell's equation, and from time varying fields we got 2 more Maxwell's equations. So total how many Maxwell's equations we got here? Totally we got 4 Maxwell's equation. 4 Maxwell's equations. So what are those 4 Maxwell's equations? So the first one is Gauss law for electric field, second one is Gauss law for magnetic field, or I can say simply B field, right? And then Faraday's law, and then modified Ampere's law. So these are the 4 Maxwell's equations. Understood? Okay, okay. Yeah. So here generally the students may get one doubt here. Sir, here you are saying this as Gauss law for electric field, and here Gauss law for B field, and here Faraday's law, and here you are saying modified Ampere's law. So whenever you are saying law here, so here you are mentioning the scientist name, that is Gauss. Yes or no? Gauss law for electric field, here Gauss law for B field, and here Faraday's law, and here modified Ampere. Ampere is the scientist here. So Ampere's law. So that means this law, this first Maxwell's equation, or this law is given by what? This law is given by Gauss, and this law is also given by Gauss only, and this law is given by Faraday. Yes or no? And this law is given by Ampere, right? And the contribution for this modified Ampere's law, the contribution for this modified Ampere's law. See, actually Ampere's law is given by the Ampere, but this modified Ampere's law, who has modified the Ampere's law is nothing but James Clerk Maxwell. Okay, so James Clerk Maxwell has modified this Ampere's law. So that's why it is called as a modified Ampere's law, right? So whenever you are saying the law, you are representing its corresponding scientist name, but we are writing all these laws, right? And here I am saying simply Maxwell's equations. All these together I am calling them as Maxwell's equations. See here, whenever I am saying Maxwell's equations, here I am not saying this as Maxwell's laws. I am saying this as what? Maxwell's equations. So which means Maxwell has formulated all these laws of electromagnetism into 4 simple mathematical equations. Who has given the mathematical forms for this laws here is nothing but Maxwell. So that's why all these laws together we call them as what? We call them as Maxwell's equations. So the mathematical forms of these laws is given by Maxwell. So that's why we call them as Maxwell's equations. Understood? Okay? Okay. So that is the reason why we call all these laws together as Maxwell's equations. right? Okay, so I hope it is crystal clear. So Maxwell has formulated all the laws of electromagnetics, okay, into 4 simple mathematical equations, which we call them as Maxwell's equations. Understood? Okay, he has given the mathematical forms, right? So here, so 7 topics we have covered, that is up to time varying fields. So next, once we complete this time varying fields here, once we complete this time varying fields, so next we'll go for 8th topic. Next we'll go for 8th topic. So the 8th topic is the nature of transverse waves. The nature of transverse waves. So here we are going to study the properties of transverse waves, how the transverse wave looks like, and how we can represent this transverse wave mathematically. So all these things we are going to see here. Sir, why we have to study about the transverse wave? Because our electromagnetic wave here, our electromagnetic wave is nothing but what? Is nothing but a transverse wave, right? So if you understand the characteristics of the transverse wave, then you can apply those characteristics to our electromagnetic wave also. Understood? Because our electromagnetic wave is nothing but transverse wave only, right? Okay, okay. So next, so after completing this 8th topic, so next 9th topic, we are going to study uniform plane electromagnetic wave, uniform plane electromagnetic wave propagation in different media, okay? So different media. So as we move from one medium to another medium, so if you change the medium, then the medium characteristics are going to change. So once the medium characteristics changes, then how the propagation characteristics of the electromagnetic wave are going to change. So that's what we are going to study, okay? So how the propagation characteristics of the electromagnetic wave are going to change as we change the medium. Understood? Okay. So as we change the medium characteristics will change. So as the medium characteristics will change, changes, then how this electromagnetic wave propagation characteristics will change. Okay. So that's what we are going to study here, right? Okay. So this is the 9th topic. So next, after this 10th topic is skin depth. We are going to study about skin depth. Okay, we will see all these things here. As we proceed into the subject, I will explain each and every topic in detail, right? Okay, okay. So if you listen carefully to all the topics, you can play with EMT, right? That's for sure, right? 10th one is skin depth. Next, 11th topic. So 11th topic is pointing theorem. So next one is a pointing theorem, right? Okay, okay. So this is the 11th topic. So note it down here, note it down all these topics, right? 10th topic is skin depth, 11th topic is pointing theorem, right? Okay, okay. So next one here, next one. So 12th topic, I think we have completed 11 topics. Then 12th topic, the name of the 12th topic is transmission lines. Next we will start with transmission lines, right? So in transmission lines itself, we are going to cover the S parameters. So I am not representing the S parameters separately. So in the transmission lines topic itself, we are going to cover that topic, that is S parameters, right? Okay, right. So once we complete the transmission lines topic, then the 13th topic is wave polarization. Then we are going to cover wave polarization, right? So once wave polarization is completed, then we are going to study about boundary conditions. Boundary conditions. See, why I am explaining the boundary conditions here means these two topics here, wave polarization and boundary conditions, these two topics are going to play a very important role in understanding normal incidence, oblique incidence and waveguides topic. Okay. So immediately after these topics, we are going to start the normal incidence, oblique incidence and waveguides. So there we are going to apply the concepts of this wave polarization and boundary conditions. So that's why I am teaching this topic here, right? Okay. So the 13th topic is wave polarization, 14th topic is boundary conditions. Next, immediately after this, the 15th topic. The 15th topic we are going to cover is laws of reflection and refraction. Laws of reflection and refraction. Right. Next, 16th topic. So after laws of reflection and refraction, so we are going to cover normal incidence. We are going to cover normal incidence topic, right? So once we complete the normal incidence topic, then we are going to cover how to represent. We will see how to represent a wave, propagating in arbitrary direction. So that means here we are going to see how to represent a three-dimensional wave. So that's what we are going to see here, right? Okay. So this is the 17th topic. So I hope it is clear, right? Okay. So 12th is transmission lines, 13th is wave polarization, 14th is boundary condition, 15th is laws of reflection and refraction, 16th is normal incidence, 17th topic is how to represent the wave propagating in an arbitrary direction. That is we are representing a three-dimensional wave, right? Okay. So next, after this 17th topic, we are going to cover oblique incidence. Okay. So here we are going to see what is parallel polarized wave and what is perpendicularly polarized wave. Okay. So if you are having the combination of parallelly polarized wave and perpendicularly polarized wave, then how to deal with that. Okay. So all these things we are going to study here in case of oblique incidence, right? Okay. So once we complete the oblique incidence topic, then the 19th topic is nothing but waveguides. 19th topic is nothing but waveguides. So in waveguides, what are the topics that we are going to cover? So in waveguides, we are going to start with a parallel plane waveguide. And then after this, we are going to study rectangular waveguide. So once we complete rectangular waveguide, then we are going to study circular waveguide. Understood? Okay. See here, this parallel plane waveguide topic is not present in the syllabus. But we have to study this parallel plane waveguide here because it is going to provide a strong foundation for us to understand the rectangular waveguide and circular waveguide. See, whatever the concepts that we are going to build in case of parallel plane waveguide, so the same concepts will be present for rectangular waveguide as well as what? Circular waveguide. Understood? So what is the difference between rectangular waveguide and circular waveguide? Only the shape. Here the cross section is rectangular and here the cross section of the waveguide is circular. That is the only difference. Understood? So remaining all the other concepts will remain same in case of rectangular waveguide, whereas in case of circular waveguide also. So the concept will be same. Understood? Okay. Only the shape of the waveguide is changing, but the concept will remain same, right? So as the shape changes, then how the fields will look like. So that is what we are going to study here, right? Okay. Anyway, we are going to study in depth of these waveguides as we proceed into the subject. So don't worry about that. So this parallel plane waveguide is going to form the basic foundation in order to understand this rectangular waveguide and circular waveguide, right? Okay. So next, after waveguides here, after waveguides, next topic is antennas. Next topic is antennas, right? So in antennas here, in antennas, what are the topics that we are going to cover? So in antennas, we are going to cover antenna parameters, right? So like gain of the antenna, directivity of the antenna, polarization loss factor of the antenna, effective aperture of the antenna, efficiency of the antenna. So all these parameters we call them as what? Antenna parameters. Okay, so that's what we are going to study. And here we are going to study about some basic types of antennas. So that is a Hertzian dipole. Just we are going to have some brief view of these different types of antennas, some basic antennas, that is Hertzian dipole, and then half wave dipole, and also we will see some brief view of monopole also, monopole antenna also. Understood? Okay. Okay. So we are having n number of different types of antennas here. So there is no need to study all those different types of antennas. We have to concentrate only on few antennas. So that is few antenna types, that is Hertzian dipole, half wave dipole, and monopole antenna. Okay, this is what is present in your syllabus. Understood? So there is no need to cover all different types of antennas, right? So this is enough here. This is enough. Next, after this, we are going to study antenna arrays. We are going to study antenna arrays. Okay, so here these arrays are nothing but, these antenna arrays are nothing but linear uniform antenna arrays here. So linear uniform antenna arrays. So that's what we are going to study here in antenna arrays, right? Okay. Okay, so in order to understand this topic, so generally the students will feel difficulty in order to understand this topic here. Why means without having the basic concepts, they will directly, if you directly jump to learn antennas, you won't understand anything. So obviously you are going to feel it as difficult. See, you have to learn some basic concepts in order to understand this antennas topic. So what are those topics that you have to learn in order to understand this antennas means, first of all, you have to understand the spherical coordinate system, right? So once you understand the spherical coordinate system, then you have to understand pointing theorem in a crystal clear manner. So once you understand this pointing theorem, right, next you have to understand the concept of solid angle. So once you understand the concept of solid angle, then you have to understand the concept of radiation intensity. So if you get familiar with these topics here, okay, then only you can understand this antennas in crystal clear manner. So what are needed here? Basic things that is needed to understand the antennas, that is spherical coordinate system, pointing theorem, and then solid angle and radiation intensity. So if you understand these things, you can easily understand this antennas topic, right? Okay, and the last topic here, so I will write here itself, so the last topic, so that is 21. So you can conclude with antennas here. This is enough. Okay, but the last topic just we will touch, and we will have a brief view of optical fiber. Okay, so actually this optical fiber is the advanced topic of Emft. So it is the application of Emft. See, this optical fiber communication, and then radar engineering and microwave engineering, and even the antenna spot, all these are nothing but what? All these are nothing but advanced topics of Emft. So they are the applications of Emft. Okay, okay. So as far as the weightage is concerned, we are having very less weightage for this optical fiber. So most probably 1 or 2 questions were asked from last 20 years, almost 1 or 2 questions were asked in optical fiber. Understood? Okay, so the weightage is very less. So we are going to have some brief view here. Also we are going to have some brief view of this optical fiber. So just some basic concepts we are going to study in optical fiber. Okay, so these are the topics that we are going to cover here. So total 21 topics, right? So all these topics we are going to cover one by one. one by one, right? Okay, so this is the overview of all the topics that we are going to cover, right? Okay, so just have a glimpse of all these topics. Just have a glimpse of all these topics, right? Okay, so the weightage is 8 to 12 marks, right? Here we are going to deal with the vector quantities and vector operations. So the first topic is introduction, basics of vectors, coordinate systems, and then del operator, and then after that we'll start with electrostatics. Here we have to study electric field and Gauss law for electric field, and some basic view or brief view of electrostatic potential, and then we'll start magnetostatics. Here we must have some brief view of Lorentz force equation and Biot and Savart's law. See, even though these topics, Lorentz force equation, Biot and Savart's law, are not present in your syllabus, still you have to have some at least minimum idea of this topic here, so that you will get familiar, with electric fields and magnetic fields. Okay, so that's why you have to start, you must have some brief view of electrostatic potential, some brief view of electric field, some brief view of Lorentz force equation, some brief view of Biot and Savart's law, so that you will get some familiarity, or you will get an idea how to deal with electric fields and magnetic fields, and also you will get an idea of the characteristics of the electric field and magnetic field if you study these topics here. Okay, so that's why irrespective of the syllabus, you must have at least minimum idea of these topics, right? Okay, next we have to study Ampere's law, and then Gauss law for magnetic field, right? And then we'll enter into time varying fields. So once we complete the statics part, then we'll enter into time varying fields. Here we are going to cover Faraday's law and modified Ampere's law. So the credit for the modified Ampere's law, who modified the Ampere's law here, is nothing but James Clerk Maxwell. Okay, it is the turning point for the discovery of electromagnetic waves. So that we are going to discuss. As we proceed into the subject, we will discuss all those things, right? So next, nature of transverse waves. Why we have to study about transverse waves means our electromagnetic wave is nothing but a transverse wave. That's why. Next, ninth one, we are going to study the wave propagation in different types of medium. So as we change the medium, how the propagation characteristics of the waves are going to change. That's what we are going to study here mainly. Next, 10th topic is skin depth, and then 11th topic is Poynting theorem, right? Once we complete this, then we'll enter into transmission lines topic, and here itself we are going to cover the S parameters topic also. Okay, I have not specifically mentioned that S parameters, so it will be included in transmission lines topic itself. Next, after this we will cover the 13th topic, wave polarization, 14th boundary conditions, then laws of reflection and refraction, and then normal incidence, and then we will see how to represent the wave propagating in an arbitrary direction, or I can say simply how to represent the three-dimensional wave, right? Next, after that we will see oblique incidence. Next, waveguides. In waveguides we are going to cover parallel plate waveguide, rectangular waveguide, and circular waveguide. Why we have to study parallel plane waveguide? All those reasons I have already given, right? Next, 20th topic is antennas. So I have given here the topics that are needed in order to understand this antennas topic. So in antennas, what we are going to cover? Antenna parameters and some few antenna types, that is Hertzian dipole, half wave dipole, and monopole antennas. Some basic antenna types we are going to cover here. After that we will go for antenna arrays. So here these arrays are nothing but what? Linear and uniform antenna arrays. So this is what we are going to cover, right? Okay, so with this we will complete the antennas topic. Most probably the syllabus will end up here itself, and just we will have some brief view about the optical fiber also. It is just an extension to this subject, right? Okay. So here in this lecture I have given all the overview. Of all the topics that we are going to cover in the next lectures. Understood? So from next lecture, in the next lecture we are going to start with the introduction, right? So that is the first topic of our syllabus, right? Okay, so I hope you have enjoyed this session. So we'll meet in the next lecture, right? So thank you for watching. So okay, then take care. Bye bye.